Hi everyone, welcome to Rodha. My name is Apurv Tandon and I'm a QN LRDI faculty here. So in today's video, we are discussing one of the sets that came in our Rodha CAT Mock 1, right? RCM 1. Now, I would say the level of difficulty of this set was not it was not on the very difficult side, but then the set was slightly on the trickier side. You have to, keep your eyes wide open when you're solving this particular set here, right? So you have to look for the little nuances in the set, right? You just cannot, straight away. It's not a set where you read the question, you mark the answer, right? You have to use your brain. You have to think a little. You have to do a bit of here and there of numbers, right? So it's a slightly complicated set, a typical CAT level set, right? Which would ideally take 15 minutes for you to crack in CAT scenario, right? So given the pressure of the exam as well, right? So let's get started with the set here. Let's understand what is happening in this particular set here, right? Now it says here the following table represent the details regarding the number of athletes who participated in an Olympic event where the four sports, swimming, athletics, gymnastics and cycling were contested. Alright, so it's basically a 4 variable Venn diagram set that is pretty sure here, right? Now it talks about four these things here, which is swimming, athletics, gymnastics and cycling were contested, right? Now each athlete who participated in the event competed in at least one of the four sports. So everybody is competing in at least one of the four sports. That clearly gives me an indication that there is none is equal to 0, right? There's nobody who's not participating in any of the four sports. All right, now let's look at this table here. So it says number of persons of age more than 60 years who participated. So this is the number of people of age more than 60 years who have participated, right? Then we have number of persons of age more than 30 years but less than 60 years, right? More than 30 but not more than 60, right? That is 13, that is the 30 to 60 bracket, right? And this one is number of persons of age not more than 30 years who participated. So somebody who's less than 30. All right, number of person who participated only in this particular sport. So can I say this is the value of only swimming, only athletics, right? Only gymnastics and only cycling, right? So this is only gymnastic here and this is only cycling here, right? All right, now let's try to figure out the number of people who are participating in each of these sports, right? So for swimming, it's gonna be the sum of the entire first row, right? So I can say 110 plus 90 is 200, 200 plus 100 is 300 plus 50 is 350, right? Sorry, my bad. This 100 is exactly 1, right? But these are the number of people. So 110 plus 90 plus 50, that is the number of people in swimming is 250, out of which exactly one sport is 100, right? Exactly one sport, that is the number of people who participate in only swimming is 100. So can I say remaining would be 150 which participate in, I can say 2 sports or 3 sports or 4 sports, right? Similarly, I can find for athletics, gymnastics and cycling as well. Let's see. 30, 60 is 90, 90 and 110 is 200. If I remove the 40, so this value will be 160 here and this is 200, right? Now, similarly, 40 and 50 is 90, 90 plus 60 is 150. If I remove the 30, this value will be, I can say 120. The people who participate in exactly 2, exactly 3 and exactly 4 sports, right? Now, cycling is 30 plus 70 is 100, 100 plus 70 is 170 total people, out of which if I remove the 20, so this will be 150. All right. So this is the typical information that I have from this particular set here. Let's move ahead to the questions and let's see how do they look like. Now, what is the minimum possible number of athletes who attended the Olympic event? All right. So let me take one by one. So let's say swimming is this one, right? Then we have, let's say athletics. Then we have gymnastic. And we have last one is cycling, right? Now, total number of people who swim is nothing but 250. So this value is 250, right? Then we have 200 as athletics. Then we have 150 as gymnastics. And we have a cycling as 170. So these are the number of values that we have here, right? All right. Now, I hope you guys understand what is swimming. So swimming is, can I say this entire part? This entire part represents the area of swimming, right? This is entirely swimming, right? This entire is basically athletics, this one, right? This is athletics here, right? If I talk about gymnastics, so this entire is gymnastic here, right? So these are the regions that they represent. Now, can I say this region, this one and this one, they represent exactly one, that is only cycling, only gymnastic, only athletics, only swimming, right? This one, all the 4 corners here, right? And this region represents exactly 2, right? These are the regions that represent exactly 2. That is any combination of exactly 2 sports, right? The corner 4 and this one and this one, right? So these all represent exactly 2. Then these are the diagonal, this diamond formed here represent exactly 3 people who participate in exactly 3 sports, and this your region here is nothing but exactly 4. For example, if you talk about this one, so we are getting the swimming inside this, we are getting the athletics inside this, and we are getting gymnastics inside this, right? So these are the people who participate in swimming, athletics and gymnastics only, right? If I talk about this region, so we have all the 4. Swimming is also here, athletics is also here, gymnastics is also here, and cycling is also here. So if all the 4 are here, so all the 4 people, this region represents exactly 4 here, right? Now, what is the minimum number of possible athletes who attended the Olympic event, right? Now, if I want to minimize the number of possible athletes, right, so I'll try to maximize the common, right? I'll try to maximize my common, right? If more the common, the lesser is the number of people, right? So can I say first I'll put the only swimming, only this thing values, right? So only swimming is 100. So only swimming is 100. So I'll say this value is 100 here, okay, right? Then we have only athletics is 40. So this is 40 here. Only gymnastic is 30. And only cycling is 20. So these are the values here, right? Now, if these are the values here, so can I say that out of 150, 30 is gone, so 120 remains here, right? 170, 20 is gone, so 150 remains here, isn't it? From 240 is gone, so 160 remains here, and from 250, 100 is gone, so 150 remains here, right? Now, what can be the maximum common, right? What can be the maximum common value for exactly 4, right? So if you see 120 remains here, 150 remains here, and 160 remains here, and 150 remains here. So can I say the maximum common can be 120, right? Now, if this value is 120, so can I say all these values will become 0, because now gymnastic 150 is complete, right? So if this is 120, so 30 of cycling remains, right? Then we have, I can say 40 of athletics remain, and 30 of swimming also remains, right? Now, if 30 of swimming also remains, so let's see. Now, my next step target will be to maximize exactly 3, right? Now, there's only one box of exactly 3 left, which is swimming, athletics, and cycling, right? Now, if I say, you can see a 40 here, you can see a 30 here, and you can see a 30 here, that remains, right? Now, if I take, let's say, for example, if I take 30 common here, right? So this is done. In that case, this is also done, right? So if these two are done, so this is 0, and this is 0. So can I place this 40 somewhere? Out of 40, 30 is here, let's say. So still, can I place this remaining 10 somewhere? No, right? There's no place to, there's no space to place the remaining 10, isn't it? Where would the 10 go? Out of 40, if I'm putting athletics, 40 remain, right? So if I put a 30 here, 10 remains here. This is 0, fine. This is 0, fine. But I cannot say that this can be 30. Why? Because there is still 10 people left, and I don't have any space to put these 10 people inside this diagram here, right? So that implies that this value for sure cannot be 30, right? So now, if this cannot be 30, so let's take it as 20. Let's start with 20. If I take it as 20, right? So can I say out of 30, 10 will remain here, right? 10 remains here, and 20 remains here, right? And 20 remains here, isn't it? Now, if I put a 10 common between athletics and cycling, if I put a 10 common here, right? So this 10 is gone, and this 10 will remain here out of 20, right? And this is still 10, and I can put a 10 here, and this is 0, right? In that case, can I say I'm satisfying all the values? Let's check. 100 plus 10 is 110, plus 20 is 130, plus 120 is definitely 250, right? 10, 40, 50, 20, 70, 10, 80, and 200, right? 30 and 120 is 50, 120, 20, 140, 10, 150, and 220, 170. So everything is getting satisfied. All the values are satisfied here, right? And also I have maximized this value, because when I took this as 30, this was not working out. Why? Because 10 was remaining here. But when I took this as 20, this is definitely working out, right? So can I say the minimum number of athletes who attended the Olympic event is going to be nothing but the union of all the values that are placed here, right? So what is the union? Let's add everything here. So 100 plus 40 is 140, plus 10 is 150, 150 plus 30 is 180, 200, and 320, and 340, and 10, 350. So the answer should be 350 for the first question here. All right, let me recheck once. 100 plus 10, 110, 150, 180, 200, 210, 210 and 220. 120 is 330, and 20 is 350. Yes, so that should be definitely my required answer. All right, let's move ahead to the next one here. Now, what is the maximum possible number of athletes of age more than 60 years who attended the Olympic event? Now, I want to maximize the number of people of age more than 60 years who attended the Olympic event. All right, let's see. So can I say, I'll say swimming, So I'll write with only SW. Then we have athletics here, right? Then we have gymnastic here, and then we have cycling here, right? Now let's see the maximum number of people who are more than 60 years and attended the Olympic event. All right, let's see. Now, as per the data, the number of persons of age more than 60 years who participated, right? Now, if I want to maximize, right? Remember, if I want to maximize, I will try to minimize my common area. The lesser the common, the better it is, right? So I'll try to put everything in: only swimming, only athletics, only gymnastic, only cycling, right? I'll try to pull in all the values in this exactly one region. Why? Because lesser the common, the more it is maximum, right? So I can say here, there are 100 people who have participated in exactly one sport. Can I say all 50 of them can be more than 60 years, right? Because the number of persons of age of more than 60 years who participated is 50. And because I'm trying to maximize the number of people of age more than 60 years, so I'll say all 50 of them are, let's say, of only exactly one sport, that is only swimming, right? I'm gonna put nothing in common for 60 years, people beyond 60 years. Why? Because if I put nothing in common, in that case, it is gonna work out well for me, right? Now, another one is athletics. Let's talk about athletics here. So athletics is 40 people who participated in exactly one sport, and 30 of them can be, I can say, in the more than 60 years who participated, right? So on 30 of them are more than 60, so I'll put all 30 here in athletics here, right? Now, if I talk about gymnastic and cycling, let's talk about gymnastic and cycling, right? The number of persons of age 60, more than 60 years are 40 here, right? But the maximum number of people who can participate in only one sport is 30. So can I say only gymnastic I can put 30, right? Only gymnastic I can put 30, but still there are 10 people remaining who are more than 60 years, right? There are still 10 people remaining here who are more than 60 years, right? And I can put them somewhere, right? I can place them somewhere. Let's see, we'll try to work that out, right? Now, cycling has 30 people of more than 60 years, but only 20 of them participated in exactly one sport. So if I utilize the entire 20, in only cycling, still 10 people are remaining here of more than 60 years. Now, can I put this 10 people common in gymnastics and cycling? Yes. If I put these 10 people who are more than 60 years in gymnastics and cycling, then can I say I'm maximizing my value? Isn't it? I'm maximizing my value of more than 60 years. So the number of people of age more than 60 years who attended the Olympic event can be nothing but, I can say, the sum of these values, which is 50 plus 30, that is 80, right? 80 plus 30 is 110, plus 20 is 130, plus 10 is 140, right? So it's just that you have to understand that when you're maximizing, you have to minimize the common, right? You have to minimize the common, right? Like here in this particular case, I straight away maximize the common 120. Why? Because I have to minimize it. Here I'm supposed to maximize this value, so I'm minimizing the common here. So I'm taking only as much as I can take in only one, right? Why? Because understand, for example, let's say, I'll just take a normal example for you guys, right? Just a small 2 variable Venn diagram, right? Let's say one is, let's say one is cricket and the other is football, okay? Now, I'll just expand these a little, alright? Just understand why do we, minimize and maximize. How do we minimize and maximize? Just a bit of basics here, very basics, right? For example, let's say if this value is 50, okay, only this is 50 and this is, let's say, 40 and this is 10, right? So right now, what is the union of this entire? Can I say the union is 100, isn't it? Now, if I make this 9, right? If I make this 9 here, isn't it? So can I say this will become 49 and this will become 39? Why? Because from both of them, there would be one less, right? Let's say this is 50 total and this is 60 total, right? So if I want this to be 50, so if I'm making this 9, right? So if I'm lessing 1 here, not 39, sorry, my bad. If this is 50 here, so I can say if I'm making this less, right? So if I'm making this 9, this will become, in that case, 41 and this will become, in that case, 51, right? If I make this 11, okay, if I make this 11, so this will become 39 and this will become, I can say, 49 here, right? Now, what do you observe here? When this value was 10, the only one was 50 and 40. The summation of only one was 90, right? When you decrease the common, when you made it 9, it became 51 and 41. That is the only one became 92. So can I say it got maximized? right? The moment I decrease the common by 1, this total increased by 2, isn't it? When I decrease this common by 1, initially that was 90, now it has become, I can say 50 and 40, 90, that is 91 and 92. And if you see here, 51 plus 9 is 60, and 60 plus 41 is how much? I can say 101, right? Now, 51 plus 9 is 60, and this is 41, which is 101. So my union has increased by 1, right? My union, which was 100, now it has become 101, but my exactly 1 has become 51 plus 41, that is 92, which was initially 90, right? But the moment I increase the common by 1, my exactly 1 decreased by 2. 49 plus 39 is basically, I can say 40 and 30 is 70, and 18, that is 88. From 90, it went to 88, right? So are you guys understanding the funda that the moment if you have more common, your single value is going to go down, right? If your common is lesser, your single value is going to increase, right? So that is the logic which you should know by now. Considering you're very close to CAD, you should understand these things, that if more the common, then the lesser is it is getting minimized, the union part, the sum of all this. And if you want maximum value, then you should minimize the common. That is why I've taken exactly 1 as 50, 30, and I could only take 30 and 20. Why I could only take 30 and 20? Because the number of people who participated in only sport was 30. If this value was 40 and the number of people of more than 60 years was also 40, then I would have taken the entire 40 in only gymnastic, right? If this value was, let's say this value was 50 here. So this value was 50, I would have taken the entire cycling, right? Inside only cycling, isn't it? Why? Because I was maximizing for it. So I hope I have made myself very clear in this particular question. You guys are able to follow. Let's proceed ahead to the next one. It says the number of athletes of age not more than 60 years who attended the Olympic event is at least. Alright, so the number of athletes of age not more than 60 years who attended the Olympic event. Alright, let's see. So let's try to work this out. The number of athletes of age not more than 60 years. Okay, so I have to focus on at least not more than 60 years. So we have swimming, athletics, gymnastic and cycling. These are the 4 events here, right? So swimming, athletics, gymnastic and cycling, right? Now my focus is on the age group not more than 60 years, and I just want to find the at least. That means I am supposed to minimize, right? So I am supposed to minimize, so I'll try to maximize the common here, right? Now let's see here. The number of people in the swimming category of not more than 60 years. Can I say this plus this? So that is 200 people, right? So there are exactly 200 people who participate in swimming and who are not more than 60 years, right? Now what about athletics? Let's talk about athletics. So athletics, there are exactly 170 people of age not more than 60 years. These two represent not more than 60 years, right? So this value is 170, isn't it? Gymnastic is 110, right? And cycling is 70 and 70, 140, right? So remember, I don't want to focus on the people who are more than 160 years, right? If there is something value that I need to consider, I'll take that into consideration, right? But I'm not focusing on this one, right? My focus should be on these 2 columns here, right? Because I want to try to minimize the number of people of not age more than 60 years who are participating in the Olympics event, right? That is, I want to find the union of all of them, right? Okay, now understand here that the number of people who participated in exactly one sport in swimming is 100. Please understand, guys, please focus a little here, that the number of people who participated in exactly one sport, that is swimming, is 100, right? Out of which 50 people are more than 60 years. So can I say remaining 50 would be less than 60 years, right? So they are in my category. So can I say only swimming in for this? So this is a Venn diagram for not more than 60 years. So this value here should be definitely 50, right? This is a Venn diagram for age not more than 60 years, right? This is the Venn diagram for the age group of not more than 60 years. So this value should be definitely 50, right? Now let's talk about athletics here. If you talk about athletics, there are exactly 40 people who have participated in exactly one sport. Even if I put 30 people of more than 60 years in exactly one, can I say still 10 remain, which will be of less than 60 years? So can I say only athletics will be nothing but 10 of not more than 60 years, right? Now what about gymnastic and cycling? So gymnastic is 40 people here, isn't it? And only one sport is 30. So can I say the remaining 10, wherever they go, I'm not concerned, because I'm only focusing on people who are not more than 60 years of age, right? So even if the 10 are more than 60 years, I can put them anywhere later, but my focus is currently on not more than 60 years. So only gymnastic for not more than 60 years can be 0. Similarly, cycling, if you see, there are 30 people who are more than 60 years, but only one is 20. So can I say only one is 20? In that case, the remaining 10 who are more than 60 years, wherever they are, I'm not concerned. But one thing is for sure, that in this 20, I don't need anybody who is not more than 60 years. But in these two cases, I definitely need 50 and 10 people who are not more than 60 years. Why? Because more than 60 years can only account to 50 and 30 in the respective values. Out of 40, only 30 of them can be accounted from more than 60 years. So remaining 10 have to be not more than 60 years. So I need to take that data into consideration. But gymnastics and cycling, the people who remain are more than 60, and I'm not concerned with that, right? Now, because I'm trying to minimize this value here, so can I say the maximum common here can be 110, right? Now, if this is 110, so gymnastics 110 is complete. So can I say all of this should be nothing but 0, right? Now, out of 140, if 110 is done for cycling, so can I say 30 remains, right? Here I can say 110 and 20, so 50 remains here, right? And 160, so again 40 remains here, right? Out of swimming out of 200, right? Now I need to account for these 40, 50 and 30 people, right? Now the next step should be, once I have maximized my exactly 4, my next step should be exactly 3. I should try to maximize the 3 common. So these are already 0. So the only place left here is this one, right? Now if I'm trying to maximize this, so the maximum common that I can have is 30, 40 and 50. So the maximum common that I can place here is, let's say, 30, right? Now if I place a 30 here, so this will become 0, this will become 0, right? Now out of 50, 30 is gone, so 20 remains here, right? And 10 remains here. Now even if I put a 10 common, where would the remaining 10 of athletics go who are not more than 60 years? Do I have any space to fill them? No, right? I don't have. So what does it imply? It implies that I cannot have 30 common here. This is incorrect. So I'll just get rid of this 30. This is not possible, right? So the next possible number that I can take common is, let's say, 20, okay? Now if I put in 20 here, so can I say 10 remains here, right? 40 remains here, 30 remains here, and 20 remains here, right? Now 20 and 30, even if I put a 20 common here, so again 10 would remain here. So this is done, right? Now 10 remains here and 10 remains here, which I can put a common here, right? And I can fill in this value, right? So next possible, exactly 3 common maximum possible value was nothing but 30, isn't it? 20, 30 didn't work out, so 20. So what is the number of people who are not more than 60 years who attended the Olympic event? Can I say the union of all these values? Let's add them. What is this value? 50 plus 20 is 70, 70 plus 10 is 80, 80 plus 20 is 100, 210 and 10 is 220. So the required answer to this particular question should be nothing but 220, right? Very important to understand how to approach this, right? Very important to understand. Suppose if you took more than 60 years, if you were taking the entire thing into consideration, if you were taking the entire set into consideration for this particular question, then your data would have become very complex, right? It would have become very difficult for you to solve. But the moment I switched to only not more than 60 years, what my question was asking, I focused only on those 2 columns, then it became slightly easier for me, though not very easy, but again slightly easier, right? And you have to develop this logic, you have to practice a lot of sets of Venn diagram to develop this particular logic, that when to remove a case, when to include a case, right? This is something that can only be built with practice, a lot of observation and practice. So whenever you're solving Venn diagram sets, please make sure that you're observing what is happening in the sets. Like here in this particular set, make sure that you observed here that when I was trying to maximize the number of people, I tried to put all of them in exactly one region, right? When I was trying to solve this question, I tried to take maximum common. Why? Because I was trying to minimize. Here, when again I was focusing on not more than 60 years age group and I was trying to minimize, I tried to maximize the common. Why? Because maximum common was 110. Because anything more than 110, this value will become negative, right? This was 200, this was 170, this was 140. But anything more than 110, this values will become negative, right? So I can put maximum common is 110, right? So you have to be very active. You have to think very actively in the exam. You'll not have a lot of time to work out on cases and sit back and take a back seat and relax. Okay, let me think what can be put. You don't have that kind of time. 40 minutes you have to target 2 sets in CAT, right? So you have to be very proactive in your thinking. You have to think on your toes. And when will that start happening? When you have practiced a lot of sets, you have observed a lot of sets, and that knack of solving puzzles comes naturally to you, right? That can only come with practice, guys. All right. Okay, meanwhile, let's continue with the set here. So let's move to the next one. It says the number of athletes who participated in all those 4 sports is at most, right? Now we have already done this part here, right? The number of people who participated in all the 4 sports is at most. after removing exactly one, I was left with these values, right? After removing exactly one sport for each of them, I was left with set of these values here, right? Now the maximum common that I can take is 120, because the moment I go more than 120, gymnastic will become negative, right? So the maximum common for all the 4 sports at most is definitely 120. So this was a cakewalk question, nothing to solve in this. The maximum common is definitely 120 here, right? Let's move to the last question for this set here. It says the number of athletes who participated in exactly 2 of the 4 sports is at most. Okay, exactly 2 of the 4 sports. Let's see. So I can say swimming, athletics, gymnastics, and cycling, right? Swimming is 250 in total, right? Then we have athletics as 170, right? We have gymnastic as, I would say, 110, and that is 140. No, that this is for not more than 60, sorry, my bad. 250, 200, 150 and 170. Okay, 250, 200, 150 and 170. So this is 200, my bad, sorry guys. So this is 200 and this is 150 and this is 170. Alright, these are the values here, right? Now if you see here, yes, 250, 200, 150, 170, right? Now exactly one sport is 140, 30, 20. So exactly one sport is 140, 30 and 20. So I'm gonna put 140, 30 and 20. So this is 100, this is 40, this is 30 and this is 20, right? Now can I say 140, 30 and 20 is nothing but exactly one sport, right? Now because I'm trying to maximize exactly 2 of the 4 sports, right? So what I'll do here is let me put exactly 3 and exactly 4 as 0, right? I'll put exactly 3 and exactly 4 as, let's say, all of this as 0, because I'm trying to maximize. I'm trying to, the number of people who participate in exactly 2 of the 4 sport is at most, because I'm trying to maximize exactly 2. So I'll put all of this as, let's say, 0 here for a moment, right? Now if I put everything as 0, right? So let me take some variables here. Let me just plug in some variables. I'll say, let's say this is A, this is B, this is C, this is D, this is E, this is F, right? So I want the maximum possible value of A plus B plus C plus D plus E plus F, right? Now if you see here, can I say A plus B plus F, this value here should be equal to how much? If the total is 250, so remaining is 150, right? If 100 is gone, so remaining is 150, isn't it? Can I say B plus C plus E? What will be this value? Out of 200, 40 is gone, so remaining is 160, so this value is 160 here, right? Now if I talk about gymnastic, can I say A plus C plus D should be equal to nothing but 120, right? If this entire region is 150, this entire region, right? Out of which if I remove 30, so A plus C plus D will be nothing but 120, right? I'm trying to maximize exactly 2. That is the maximum value of all the alphabets in blue color, right? Then I focus on cycling, so can I say D plus E plus F should be equal to nothing but I can say 150, right? Now if I add all these equations, right? So if you observe here, each of the variable, right? Like A is coming 2 times, right? B is also coming 2 times, C is coming 2 times, right? D is coming 2 times, E is coming 2 times, and F is coming 2 times, right? So can I say that twice of A plus B plus C plus D plus E plus F, right? This value should be equal to nothing but 150 plus 160 plus 120 plus 150. That is how much? 300, 460 and 120 is 580. So this total is equal to 580. So from here I can say the value of A plus B plus C plus D plus E plus F should be equal to nothing but 580 by 2, that is 290, right? So the required answer will be option number B. And why is this the maximum value in itself? Why? Because I have already minimized this exactly 3 and exactly 4, which is 0. So when I have already substituted this values in 0, right? And these values are fixed, so automatically I'll be getting the maximum value of this, right? So this is coming out to be 290. And I'm not concerned with the nuances of these variables. What will be A, what will be B, what will be C? I can plug in anyhow, I can adjust the values for sure, right? So you don't have to jump into these, settling these values. Okay, what can be the maximum common A here, what can be C here, you don't have to do that. You have to just find the maximum value of exactly 2. So the maximum value of exactly 2 is coming out to be nothing but 290. Alright, so with this we come to the end of this beautiful set that was asked in RCM 1, right? I'll be recording few more sets of our RCM 1 and RCM 2, and which will be uploading here on YouTube channel, which was free, which was an open mock for all of you, and few of sections as well of our Rodha mocks here. So stay tuned, guys. We'll meet tomorrow with a new video of LRDI set from RCM1 itself. All right. Thank you, everyone.